So my name is Erin Landis. I'm with the Water Programs Manager at Wissahickon Trails. Thanks everyone for joining us today. I'm excited for this talk. We do have a pretty small group here. If everyone, usually it's helpful, folks stay muted while our speaker's presenting, just so there's not a lot of background noise. So I might mute you if I hear any background noise. If you want to introduce yourself in the chat, you're welcome to do that. You know, who you volunteer with and, you know, what town you're from or what watershed you're in. And if you have questions during the presentation, please put them in the chat. If it's something that is about a slide that Ryan is on, that's like an immediate question that can't wait to the end. I would say, Ryan, are you okay if folks unmute themselves because it's a small group?
Yeah, I mean, if it's like a pressing question, I know I'm a quick talker, just butt in and stop me and I'll be happy to explain.
Yeah, and otherwise we'll like hold the questions to the end. You're welcome to throw them in the chat just so, you know, to have it in there. And then we'll have, I think, a good amount of time at the end for question and answer. So today Ryan is going to talk to us. I think most of you probably know Ryan, but he's going to talk to us about chloride blitzes in the Tookonee Frankford watershed, and I'm really excited to hear about it. So did I miss anything, Ryan? Can I turn it over to you?
No, I think we're good. Yeah, just keep checking as people come in, filter in. So hi everyone. Like Erin said, I'm Ryan Newman, work over at Tookonee Frankford Watershed Partnership and coordinate a bunch of stuff over there, but work with our Streamkeeper program as well. I'm going to be presenting today on the chloride blitz that we did last year, a couple chloride blitzes that we did last year in the TTF specifically. Going to talk a little bit about how, if the Wissahickon and the Pennypack wants to specifically do them, they can get involved as well. And some future plans for chloride blitzes potentially in the TTF watershed this year. Talk a little bit about some of the data from last year, and then talk about some of the outcomes from the events that we did last year as well. So like Erin said, questions in the chat. I'm a pretty quick talker, so if I'm talking too quick, just let me know and I can slow down too. But there should be time at the end for questions as well. So I guess just specifically, what is a chloride blitz? So a chloride blitz is really just a quick snapshot sampling event to get a feel for what the conditions look like in the watershed throughout the year. So it's going out with either, it could be, you know, a staff person from the organization or a number of volunteers that go out over a short amount of time. Typically we've done just the same day in like a 2-hour window. It could be over a number of days, but it's during base flow conditions in the stream in the spring, summer, fall, when we typically wouldn't be seeing road salt application. So we wouldn't normally be seeing spikes in the conductivity and the chloride content in the water during that time of the year. And really the purpose of it is to get a clearer picture of what the base flow chloride or salt conditions are in our streams throughout the entire year. Again, salt's one of those things that we've more recently started to look into and how it affects our streams and the levels that we're seeing in our streams. There's been a lot of focus on the winter time and seeing those massive spikes in the winter time, but that's certainly, the salt doesn't dissipate. It's still entering the stream throughout the year through groundwater. So it's still there, and we're still seeing some pretty significant numbers. One of the important things of why we're looking at it not during the winter season is that with elevated stream temperatures, the lower levels of salt in the water can still have a pretty large effect on aquatic life in the water. So, you know, maybe 300 or 400 milligrams per liter in the winter, if it's a flash quick event and it flushes out in a couple hours, isn't necessarily as detrimental as if the entire spring, summer, fall, it's at 300 or 400 milligrams per liter. So it's just a little bit about the chloride blitz and really what it is. So I'm going to walk through sort of the basic steps of how the program sort of works, how if if the WSIC and the Pennypack or a different organization might want to do one or get involved, some of the basic steps. And we'll go through sort of at the end to the Stroud Water Research Center, who we partnered with on this and certainly couldn't have done all of this work without them. They put together a helpful guide on how to do this as well. So really the first step was selecting the sites that were going to be sampled. So there's sort of a lot that goes into that, from what type of question we're asking. Are we trying to track down a specific section of stream that's a problem? Are we really trying to get really just a feel for what the entire watershed looks like? Are we looking at specific tributaries? Other things to consider are, is it easy for volunteers to sample? Is it accessible? Is there places to park? That type of thing too are also pretty good considerations. So across our 2 sampling events that we did in the TTF watershed, we sampled a total of 32 different sites across the watershed. You can see, I think, 30 of the different sites here. So in some cases, it was along the main stem of the Tokenie Creek. In some cases, it's along smaller tributaries, and there's multiple sections where tributaries might meet. So we were really trying to figure out where there might be problem sections of stream in our watershed, because we had happenstance sort of found a couple other sections that had some pretty high chloride numbers already. So that was sort of how we fell upon the sites that we did. Again, so sort of the principle of the event is the volunteers, how we did it, they all met at a park, and then we spread out, collected the samples, and came back and analyzed the samples at the park and talked a little bit about it. So volunteers would go out and grab like 2 or 3 samples at a time and come back. So we tried to group some of the samples at least closer together. So that's why if you see here on the map, in some cases, there's a lot of points that are close together, is because it's easier to collect that many samples, and then also they're near where streams meet, or other specific areas where we sort of wanted to answer a little bit of the question. So like I said, a volunteer would go out and they would collect the samples with a bottle. So they'd go out, you do the typical protocol that we were using was you'd rinse the container 3 times with the stream water, and then get the sample on the 4th time. We'd bring those samples back because we were looking at the salt and the conductivity. We weren't necessarily worried about like refrigerating the sample or anything. The one key that was important though was labeling the sample. So we did 30 samples at our largest event. A couple other organizations that have done events since then have done in upwards of 50 samples. So really, the label is important in keeping organized in what sample we were looking at, what site we were looking at, and sort of all of that information as well. So once volunteers brought back the samples to the site, we used chloride test strips. So we had some low-range test strips on hand, which is what we used, and we also had some high-range test strips just in case. The low range goes up to 600 milligrams per liter. The high range go up to 6,000. But again, in looking during the non-peak road salt application season, so not during the winter, we weren't really expecting to see anything that would eclipse those low range test strips. If this was a wintertime event, the high range test strips can be pretty important, because I've had sites where a low range test strip is completely blown through in a matter of seconds from putting the test strip in the water. So again, we use these test strips, and then from there we collected conductivity data as well from the samples to compare with the chloride data as well. So the first sampling event that we had was on April 30th of last year. So again, this was spring, so there was a little bit higher of a water level coming off of a pretty active winter season, certainly relative to this year. A couple pretty decent sized storms and a lot of salt application. We collected 10 different samples during that event with 5 different volunteers. And so again, really for a first event, we just wanted to see how it worked. if it worked for volunteers, how easy it was to get samples. So we picked a limited number of sites, but tried to be strategic with it. So picking where tributaries might flow in and a couple main stem of the Tokenie sites as well. So here was, and let me just minimize texture a little bit. So here was the results from that first sampling event. So you can see all of these are going to be the results from the chloride test strips. So in milligrams per liter, the highest sample that we had from that event was the 236 milligrams per liter up here along Bader Creek. Bader Creek had some of the highest numbers across their sampling. We'll talk a little bit more about that later. But one thing you'll notice is all the samples that we collected were over 100 milligrams per liter. So all the samples were exhibiting some pretty decent stress levels in terms of salt in the water and its effects on aquatic life in the water. So the next sampling event we had, a bigger event. We tried to get some more specificity with the samples, see if we could have more people collect more samples. We had 10 different volunteers for this. We sampled 30 different sites. And again, clustered a lot of sites to sort of try and answer some specific questions. Like you'll notice we have 6 points on Bader Creek up here again, where we saw that high number in the spring, to try and really figure out where we were seeing, if there was a specific cause that we could pinpoint that was leading to that high number. And so now I'm just going to highlight a couple tributaries and the headwaters of the Tokenie Creek to give you a feel for what some of those numbers were. And so I'm going to flip through these a little quick. I have some charts and some graphs to talk a little bit more about some of the data that we saw from the fall as well as the spring sampling event in relation to specific thresholds and its effect on aquatic life a little bit later. But so here was the first stream segment that I pulled out. So this was along Rock Creek, which one of my stream keepers has been collecting some test strip data from Rock Creek for a number of years now and has seen some pretty high levels. But again, so we looked at the main stem of the creek as well as 2 smaller tributaries that flowed into the creek. Both the tributaries had significantly lower chloride numbers. The main stem had a pretty high number still. And I think if we went further up Rock Creek, where it joins into Philadelphia, we'd even see higher numbers actually. Next would be looking at the headwaters of the Tokenie Creek. So it starts sort of up by 309 near Holy Sepulchre Cemetery. For anybody who's familiar with the area, has a pretty small trickle. You can step across it. So we got a sample up towards that way. Still under 100 milligrams per liter, but still some evidence of some chloride pollution. And then we sampled a number of the smaller tributaries down through and saw some further elevated numbers. We didn't have any other sampling points along the main stem of the headwaters of the Tokenie until it joined with Bader Creek, which is the other major tributary. So again, it's sort of picking and choosing where you can be strategic with the number of samples that you get. You're not going to be able to cover every single part of the watershed to get a feel for what the chloride numbers might be. So here, this is along Bader Creek. So again, we had some pretty high numbers from this sampling event. You're seeing a lot of red there, which we'll talk a little bit more about when we talk about some thresholds, some orange too. But this and one other section of stream were some of the highest numbers that we had recorded. And then just the Jenkintown Creek, which is really the area that we focus a lot of our work. It's where we do a lot of our staff level sampling, had some of the lower numbers that we had seen in the watershed. So around 100, sometimes a little under 100 there as well. And so in looking at all those sections, we will go into a little bit towards the end of the presentation, talking about, well, maybe talking about land use and if that had any factor on sort of the numbers that we were seeing. So we'll go into that a little bit later as well. So just a wrap up from those 2 sampling events. So we had 15 volunteers. We had a couple of repeat volunteers who helped in the spring, who also helped in the fall, but It was a total of 15 different people who helped. They collected 40 samples across 32 different sites and across our entire watershed from all the samples we collected, which again is sort of a generalization because obviously there's some sections that are a lot higher and some that are lower, but we saw an average reading of 153 milligrams per liter of chloride from all of those samples. So now we're going to look at some charts here from those samples again and talk about some thresholds and sort of the numbers that we had seen and what that means for the stream. So here's just a chart that Strout had sort of put together from some other presentations to look at some of the other thresholds. So if we were talking about a natural stream unaffected by road salt or really human intervention in our area specifically, you're probably looking at a chloride level of 5 to 15 milligrams per liter. So if you paid attention to any of the readings that we had seen from the sampling events, we're certainly well over that. A couple other numbers here that are highlighted. So in red at the top here, that is the EPA's aquatic life. Their long-term threshold is 230 milligrams per liter. So that is, I think what it was if it's over a period of 4 days, if the number exceeds that, then there is effects on aquatic life according to the EPA. You'll see some lower numbers here. So the EPA number is from the 1980s, so it has not been updated in a long time. So that's why that number is so high. A lot of other states and other government bodies and whatnot have came up with lower numbers that still have an effect on aquatic life. The number next to that, the 860 milligrams per liter, is the acute threshold. So that's the short-term threshold. So if it's exceeded 860 milligrams per liter over 4 hours, it can have an effect on aquatic life. So the next number that we have highlighted here is the Canadian national standard for the chronic effects of chloride on aquatic life in the stream. So that's 120 milligrams per liter. That's a much more recent, I think within the last 10 years, but you'll see that's half of the EPA threshold. And then we have Ohio and Maryland both highlighted, which are the last 5 years, and their threshold for long-term effects on aquatic life is down at 50 milligrams per liter. So just keep those numbers in mind when we look at some of these charts here from the readings that we saw. You'll see that all of our samples are really exceeding the Ohio and Maryland chronic thresholds, and a lot of them are also exceeding the Canadian, not as many on the EPA, but to keep in mind that the numbers that we're seeing, although according to the EPA, they're not necessarily harmful to aquatic life, it might not be, they're still having an effect on aquatic life. So this is from our April event. So again, those 10 samples. So these are all the sites. You'll notice only one of the sites, Coates Preserve on the far right there, which is on Bader Creek. That's that one that measured 236 milligrams per liter. That was the only one that exceeded the EPA threshold. But if you'll notice, the green bar at the bottom here, that's going to be that natural level really, which that's a little bit generous. I think that goes up to like 20 milligrams per liter. But anything over that is over the natural level. So you can see that all of the sections of stream that we looked at essentially had a elevated chloride level that could be indicative of a stress on aquatic life. Again, salt isn't the only thing that's stressing the aquatic life in our streams. All of our streams in our suburban watersheds are impaired, but salt is certainly one of those pollutants that is affecting it. So here are those sampling points again from the spring. And then here is the fall, the chart from the fall sampling events. So you'll notice here immediately on the left again, pretty much all of the sites that are in the red are along Bader Creek again. The only one that's on Bader Creek that you'll notice isn't in the red is this far one on the left here at Abington Junior High School, which is one of the branches of sort of the headwaters of Bader Creek. So I'll talk a little bit about it later, but essentially from some of the data that we've been collecting here from these chloride blitzes, we're hoping to do a little more intensive monitoring to see if we can pinpoint what's leading to the high numbers in Bader Creek, since there is one section of stream in the headwaters that isn't as elevated as the other sections. Again, though, you'll see elevated levels across the board on a lot of our streams. Some of the smaller tributary sections that are in some of our more forested environments, which is being generous. In the TTF watershed, it's pretty developed, and in a lot of our suburban watersheds, it's pretty developed. So you're not going to see the pristine mountain streams that have some really low levels and more natural levels as well. And so here are those sampling points again. So again, we multiplied the number of sites and tried to get some specificity in where we were sampling. And then here is a comparison of the sites that were repeat sites from the fall and the spring. So I think there was 8 sites that we sampled in the spring that we also sampled in the fall again. We were hoping to sample all 10, but just the way it shaked out with the volunteers and the ease of access and sampling some of the sites, we only got back to 8. You will notice, so in the light blue bars are from the fall, the dark blue bars are from the spring. And again, we have the red and green for the above the EPA threshold, and then the green for the natural level as well. You'll notice in almost every case that the fall sampling event had higher chloride numbers than did the spring, which again, when we thought about it at first, we were sort of surprised because we thought with the close proximity to the winter season in the spring that the spring levels would have actually been higher. But tracing back to the sampling days and looking at the water level on some sections of stream, we think that the water level was lower in the fall based off of a drier summer, and that the lower water levels led to a higher concentration of chloride in the water, which led to some higher numbers in the fall. I think there was one outlier site on here, which I'm trying to find, but 7 of the sites had a higher level in the fall than it did in the spring. So talking about sort of the effects of land use. So that was one of the questions that I guess when we first did the sampling event here in the spring of last year, when we were talking about site selection, I was looking at some subwatersheds and looking at land development and seeing how developed all of those subwatersheds were. One of the things that is sort of indicative of all of our suburban watersheds, but specifically the TTF sort of has the challenge of there's no like land trusts like Wissahickon Trails or the Pennypack Trust where they're preserving land sort of up towards the headwaters. The TTF is really built out a lot. So this map you'll see here is just highlighting in red all the areas in the Wissahickon, Pennypack, and TTF watershed that are residential land use. The green is not necessarily undeveloped areas. That's just other uses. So in our suburban watersheds, 54.6% or over half of the land use is residential properties. So what that means is in some cases, the creek is flowing through people's backyards. In some cases, it's flowing through their front yards. It's under their houses enclosed in pipes. It's exposed in their front yards, channelized. So that's one thing to think about when thinking about chloride levels is it's not necessarily just municipalities salting the roads. There's a lot of residential land use and a lot of residents applying salt as well. So when thinking about those effects, it's also important to think about what people are doing at home too. But going back to the main point here of land use in our watersheds, you'll notice this small pie chart here at the bottom left. There is one small bar, which is this one here. If everybody can see my cursor, that is wooded across all 3 of our watersheds. So again, most of the land is developed specifically for the TTF watershed. When collecting all of these samples, there was no real correlation between how developed the subwatershed was, or the section of stream that we studied, versus other sections of stream that we studied in the watershed, just because it was so developed. There might be a threshold of lower development where maybe if 30% of the watershed is developed, there'd be lower salt content in the water, or maybe it's 50. In our case, I think every subwatershed that I looked at was over 50% developed. Most of them were in the 60, 70, 80% development. So it was tough to get a read on if land use had a big effect on how high that chloride level was going to be. Again, the difference between 90% developed and 75%, in the scheme of this, we didn't necessarily see a huge difference. So that's one of the things in thinking about future directions. If there's sections of stream on the Pennypack Creek, I know there's a couple sections on the Trust, or if there's sections of the Wissahickon that are less developed that we could look at and use as a comparison to see if, maybe there's a section of stream that's 90% protected and on forested land. Getting a sample from that stream as really a baseline reading for how low the chloride level might be in our watershed or in our surrounding watersheds, that would sort of be a critical point to look at. So that's sort of one thing to think about as you hear the presentation here of talking to Aaron, or talking to Kevin, or talking to me about the benefits of and getting scheduled chloride blitzes across all three of the watersheds. Again, they're in close proximity, they have their differences, but it would be beneficial to have a comparison of some less developed watersheds and subwatersheds and streams that are in some more forested areas. Again, in the TTF, we didn't necessarily see a correlation between land use and what the chloride level was. We saw a lot of high chloride levels, but the watershed's very developed. So I'm going to talk a little bit now about how some of the data was used that we collected, and also some of the other things that came about from doing the chloride blitz last year. So the first one of them was, again, in the spring when we did the first chloride blitz event. We partnered with Stroud Water Research Center again. They were super interested in seeing the process of how it worked, all the planning that went into it. Dave from Stroud came out and helped on the day of, answered questions, helped with some of the logistical stuff. They were interested in how organizations could use volunteers to help collect a greater number of data points on road salt in relation to streams. So as a result of that event, of the fall event, and working with Dave and talking to Dave, Stroud developed this sort of instruction manual on how to do a road salt snapshot for a watershed. So it's several pages. I could share the resource if you're interested. Stroud has it on their website too, I think. But it really walks through the process of doing a chloride blitz. So again, the spring event that we had and then the fall event were sort of pilot events to see how volunteers could get involved in collecting this data in a uniform, consistent way, where we could really get a good feel for what the chloride level was at base flow conditions in the stream throughout the year. So as a result of that, there was a number of other organizations after we did our spring sampling event through into the fall, sort of as Stroud was developing the guidelines on how to do a chloride blitz, that also did chloride blitzes themselves. So you can see some of the logos here from them, but I'm just going to read off a few of them here. So the Willistown Conservation Trust and Darby Creek Valley Association partnered on a chloride blitz. There's a great write-up on the Willistown website that talks about their chloride blitz event and some of the data that they had collected and seen Again, that's a suburban Philadelphia watershed, the Darby watershed. Valley Forge Trout Unlimited also did a sampling event. I think they did about 70 sites. What was significant about their sampling event, Valley Creek that flows through Valley Forge is a limestone creek. It's a significant trout fishery for a lot of people. They were looking at, like I said, I think they looked at 70 sites across the watershed to get a feel for what the increasing salt levels were over the years in the creek there. The Goose Creek Alliance partnered with Westchester University and Penn State Extension Master Watershed Stewards to collect some samples over in Chester County. Angelica Creek Watershed Association, which is out by Reading, if anyone's familiar, the Musconetcong Watershed Association, and the Broadhead Watershed Association. That's all the organizations that I know of right now that did chloride blitzes. But the work that the volunteers did in the spring of last year and the fall of last year that you guys helped really to pilot this, it's helped other organizations to collect data and help us to get more data across the area. I know Stroud's been excited to see other organizations collecting that data as well and getting a feel for what those numbers look like in their watershed, to give us a feel for across Pennsylvania, New Jersey in some cases, what those numbers might look like. I know some of those organizations have specific write-ups on what they've collected. Other organizations have the data on hand. If you're curious about reaching out to any of those, I could probably get some of that data for comparison for people as well to see what some of those readings are. So another thing that we did with the data that we collected specifically was we have our road salt flyer, which I'll talk about on the next slide, but really we have this map here, which is a synopsis of volunteer data collected, whether that be through these chloride blitz events, through test strip data that was part of the Isaac Walton League Salt Watch, or if it was part of their monthly monitoring. This also includes some of our continuous loggers that are out, as well as USGS continuous loggers, and then also our water samples that we collect on a staff level as well, all compiled together to give us a feel for what the chloride levels look like across our watershed, sort of as a good graphic to share with just regular constituents, volunteers, but also municipalities as well to talk about this. And so again, it's sort of a wide range of data. Some of it is water samples that were analyzed in the lab for what the chloride in milligrams per liter was. Some of it is continuous data, and then some of it's that volunteer data. So it's all different data, all different levels of data, but it all really helps to give us at least a rough idea of what the chloride levels look like in our watershed for the sake of communicating the data to people. Again, one of the biggest issues with road salt use in regards to the health of our streams is that, yes, it is harmful to the aquatic life in the streams, but is it something that people typically think about in the wintertime? No. I mean, when it snows, people are really concerned about driving and safety on the roads and whatnot. So we'll put down all the salt, and then no one thinks about what happens to the salt after the snowstorm. Obviously, it just doesn't disappear. There's not people in most cases going around and sweeping it up. It all ends up washing into our streams and elevating those numbers. So really in the stage that we're at in regards to road salts in our streams and working with our municipalities and people is really still in the education stage of saying to them, there is a problem. Here's some data to show that. You know, we're seeing elevated numbers. We know that it has effects on aquatic life as well as other effects. This is something that you should think about. So really trying to, you know, educate them, but open the conversation at least of how they can do better or why they should do better. We're not quite on the level of some of those other states in the north, northeast, and in the north in general that are a little more stringent on their guidelines and in being more proactive in regards to road salt. So here is that fact sheet again. So we worked with Stroud last year to redo our fact sheet on road salts. So it has that map that we updated. It has a couple of charts as well as a lot of other data just about road salt use that's local to our watershed. Again, if anybody's interested, I know the Pennypack redid this flyer specifically to the Pennypack watershed. We'd be happy to share, and any organization can alter it to be specific to their organization. But again, we pass this out at tabling events. We give it to volunteers. We share it with our municipalities as well to share. So that's one way that we're sort of communicating the data and using the data that our volunteers are collecting. Again, that map is updated with some of the data that they're collecting as well as some of the data that we're collecting. Another thing that we've actively been trying to do is at least once or twice annually at TTF, we host a meeting with our municipal partners as well as some of our private partners that we have restoration sites with. And last year we had a discussion on road salts at that meeting in the spring. And we had Stroud come on and talk more generally about the harmful impacts of road salts. And then this year in February, a couple weeks ago, we hosted another municipal task force, and we talked specifically about what we've been working on with our volunteers and some of the data that we've been collecting and what some of those chloride levels are in our streams. So again, that's with some of our private partners as well as our municipalities. We had a couple commissioners on, as well as some local elected officials. Really, again, just presenting the data that we've been collecting so that they can see what it is and educating them. Again, it's not something that a lot of people think about or know a lot about. So there were some questions that, were out of left field, but again, it's not really a topic that a lot of people know a ton about. So now just really, again, future directions. We had those two events last year. We collected some good data. What are we going to do now? So one of the things that the sampling events prompted us to think about was, is there anywhere that we'd want to look at more specifically in terms of chloride or more long-term? So in thinking about that, I mentioned that we had seen some high numbers on Bader Creek in regards to road salts, well higher than most of the other sections of stream. So again, thinking about why is that the case? We're not entirely positive. We have some ideas without specific data to back that up. It's tough to say, but we're in the process of working to get some continuous conductivity loggers installed in the stream to give us year-round data for comparison's sake. So we're looking at, if you can see my cursor here, putting one logger along this section of stream that's highlighted in red, and another one potentially on this section of stream up here in yellow. So again, it's both on Bader Creek. It's actually both on the same property, just different sections of the property where it starts. One of them has a significantly lower chloride level. So figuring out why that's the case and collecting the data to back that up as well. So that's sort of one hopeful outcome from the data that we collected last year that we really want to delve a little bit more into. And again, as I mentioned a little bit before, the hope is that the Pennypack and the Wissahickon can do some events this year as well, so we can compare sites across all of our watersheds. We're all sort of in the same locale. All of our watersheds meet at one point. We all have a lot of suburban development and similar challenges. And both the Wissahickon and the Pennypack have some less developed sections of the watershed where there might be some good streams that give us a better feel for what the natural levels look like. And also, again, maybe it would be beneficial in some of those cases to see if there is a land use threshold where if it's developed to 20%, maybe the chloride level is this much lower. It would be interesting to see if there are those comparisons that can be had there. And then just, this is my last slide, and then I'll open it up to questions for people. And then we might be done a little bit early too, because I'm a fast talker. But so for this year, in the TTF watershed specifically, the hope is to have a spring Chloride Blitz event on May 20th. There's a potential rain date for June 3rd now. I'm going to put more information out specifically to TTF volunteers, but also if Pennypack or Wissahickon volunteers are interested, that's sort of when I'm thinking about hosting them. I'd like to do a summer sampling event. I recognize a lot of people go away in the summer, so that might be a staff level just to try and get data points on that. And then also to do another fall sampling event this year. Again, it seems almost a little bit redundant to keep sampling the same sites, maybe adding a couple sites, but doing them all within the same year again. But it's really the more data points we have on specific sites, the better informed we can be about what those levels are to those specific sections of stream. But also, if we collect samples over a number of 5, 6, 7 years, if we start to notice an elevation, we're collecting the data to catch that then. So that is pretty much what I have in terms of presentation. So if anybody has questions now, or if there's any questions in the chat, I'd be happy to answer questions for the last 17 minutes, or if we do 10 minutes and people want to leave a little bit early, I'd be happy for that as well.
Thank you, Ryan. That was awesome. I learned a lot too. We do have a few really awesome questions in the chat, and folks can add more questions in the chat as we talk. Or it is, again, it's a pretty small group, so I think that folks can unmute themselves if they want to. First, I'm going to read the questions in the chat, and then after that, folks are welcome to unmute themselves and yeah, just ask any questions or make comments if that works for you, Ryan.
Yeah, that works.
So someone asked about how the, and I don't know if you want to stop sharing unless a question comes up about a specific slide.
Yeah, I'll stay on that in case I have to go back.
Yeah,
So.
that sounds good. So someone asked about explaining how the standards are determined for the chloride threshold levels.
that is a excellent question. Although neither myself nor Aaron are involved to that extent with making standards. I can't specifically say for a specific state or in terms of Canada why that threshold is what they determined. My best guess again is based off of data that they're collecting and giving that to decision makers, and the decision makers realizing that it's a problem. To the extent that Pennsylvania is not at that level yet, I think, where it's been identified as a glaring issue, or maybe it's just not something that they're willing to tackle. It's certainly an issue. We can see it across our streams in the suburban Philadelphia area. I know Stroud is seeing data from a lot of other places too that also sort of corroborates that. I don't make laws, so I can't specifically say how the standards are created. I could do a little more research if you're interested too, and we can share that later. That's a possibility too, but sorry, I can't specifically answer that question.
Aaron, if I may just clarify, maybe when we say the threshold standard, I was wondering, because different EPA has a different threshold, right? We can see the range between 50 to 230. Of course, some of them are based on old data, but I would think the impact to the aquatic life, I don't know if they actually did some experiments in terms of long-term exposure for aquatic life. Like if you leave a plant in a, highly, high chloride level water, how long does the plant, it's going to die, or versus the growth rate? Is that how they decide the impact? And then based on that to set the threshold, which is safe versus not safe?
So I guess sort of a little bit to answer your question. elevated levels above natural would most likely affect aquatic life, and potentially do things like stunt growth and whatnot, or do reproductive harm. Specifically though, I know places like Stroud are essentially, Stroud has a indoor stream in their basement. They're one of the leaders in freshwater research in the world. They look at the mortality of specific species of macroinvertebrates in terms of different salt levels. There's a lot of great work that they publish. So yeah, they are looking at that and looking at what levels are doing what harm to what specific types of macroinvertebrates. Again, it's sort of a sliding scale across the board where there's some super sensitive macroinvertebrates that, a very low elevated level could have harm to, and then there's some more tolerant macroinvertebrates that could certainly tolerate a much higher level. So that could potentially be something too in talking about those thresholds, is what specific macroinvertebrates were looked at in terms of the threshold too.
Okay, thank you.
So another question, let me see. Another question that came up is, do septic fields impact groundwater chloride levels? I don't know the answer to that, but I do know, so I don't think in the Wissahickon watershed we have a lot of septic fields specifically in this area. I don't know, is TTF the same, Ryan?
I mean, if we're talking in terms of if like wastewater is having an effect on chlorides, that's not something that I have wanted to look at specifically. In the TTF watershed in Philadelphia, one of the biggest challenges to the watershed is actually combined sewer overflows, which essentially means that wastewater is entering the creek during storm events. So we haven't looked at, our chloride levels and our conductivity levels in Philadelphia for one of those reasons of it may influence what we're looking at. We might see higher numbers based for other reasons besides road salt. So I haven't specifically looked at that or done a lot of research on those effects, so I couldn't confidently answer that specific question. I'm not sure, truthfully, I'm not sure if anybody would be looking or is currently looking at that.
Yeah, and Stroud might know. Stroud, they're located in a little bit of a more rural region, so they might know more about it as well.
Okay, thank you.
Of course, yeah. And then one other question from Gia. She had great questions. Thank you. So do we have data to be able to discern whether the density of the development has impact on the chloride levels?
There is certainly data out there. Again, for the sake of collecting data from our watershed, it's just a case of it's so developed. There's not a underdeveloped area to compare to. There is certainly data out there though on that. Again, some of the other organizations that have done chloride blitzes since we first did ours, they have sort of a sliding scale where they might have a little bit of a correlation too, because they are bigger watersheds. Again, the TTF watershed's only 30 square miles. Part of it's in Philadelphia, part of it's in Montgomery County. Some of those larger watersheds across bigger areas have less developed sections of stream. So there is data out there to talk about the relationship between chloride levels in our streams and land use development. That could be something if people are interested in. I could reach out to Stroud and see if they have a specific paper. Again, they have pretty extensive science staff that offers papers on related topics and stuff as well.
And Ryan, oh, sorry, Gia, were you gonna add
Oh, no,
something
I
else?
just, thank you. No additional comment.
Yeah, thank you. Those are awesome questions. I was just gonna say, Ryan, that I don't know if this is something that you could look at, but I feel like that's somewhat the point of collecting this data too, because if you have a few more rounds of data, I'm not sure if you could compare the land use to the data. It's hard to tell just with, one or two rounds.
Yeah.
But with a little more rigorous data set, that might be something that you can look at.
Yeah, and again, that's sort of the hope if Pennypack or the Wissahickon does it, is you guys
Yeah.
are so close. We would expect to see at least similar natural levels where it would be a good comparison. Because again, I've scoured the map far and wide now looking at our watershed, and I've tried to pick some areas that are as the least impact possible from humans that I could find, and it's still turning up some elevated levels.
Okay, one other question in the chat. So, and folks are welcome to keep them coming if you have any. So, are there any municipalities that appear to be in the forefront of using equipment that helps reduce excessive spreading of salt? Can you generalize or be specific about how concerned municipalities are about dealing with pollution from spreading salt on their roadways?
Oh, that's a very good loaded question as well. Again, in Pennsylvania per se, whoops. I'm not sure there's necessarily, I think around the Westchester area, potentially, there might be some movement on road salts. But again, if we were to have the Stroud people on now, they'll tell you that some of our bordering states, like Maryland, is a state that's pretty proactive, that is working on road salt application. There's some good papers out there. I watched a webinar last year from the EPA region in our area, which I can't think of what the number is right now. But they talked about on a webinar about the salt use by the Maryland, might have been the state actually, on calibrating their trucks, talking about brine use and talking about salt savings, but also what that means for the streams. So Maryland's a good state to look into on some information. I also think Vermont might be another good one. And there is some good stuff on upstate New York as well. Locally to us, again, at least from my experiences, is that it is a education process still, which again is sort of a little frustrating because again, we see the salt piles on the road, we see how much salt gets put out, and we have the data, we're collecting the data, and we're seeing some numbers that aren't good. It's talking to them and still trying to get through to them. Again, it is challenging. I don't want to say that the municipalities are bad because they haven't started to work on it. Again, it's weighing the priorities for the municipality and thinking about the financials, but also it's not easy in Pennsylvania. I mean, the weather is pretty unpredictable right now. I mean, this year it hasn't snowed really at all, but I've seen a couple times that municipalities have salted because there might have been a little bit of ice or other concerns. It's sort of a tough call. Again, I think it's sort of getting over that hump with the municipalities of saying that, like, you need to care about this, and this is what we're seeing. And it's really starting that conversation with them, not yelling at them and saying they need to do better, but of how can we do better. But again, one of the big issues with that is the state of Pennsylvania isn't exactly jumping on people and saying you need to do better. So for like stormwater management and stuff, there are state requirements and regulations for municipalities and MS4 requirements where they have to specifically do stuff. So that is a little bit more of a focus, I think, than road salt at the current moment. So again, I'm not going to say there's like a shining municipality that is at the forefront here that's really working at it that I know of locally. but it also sort of comes down to there's no one pressuring them. And again, the natural human inclination where how many people are going to do something good just because they know it's good versus because they have to do it.
Yeah, Ryan. So Jeff said that Springfield Township, and I know some other townships in Wissahickon, and I'm sure other watersheds are using brine. How much less of an impact does brine have versus solid crystals of road salt?
So again, I'll touch a little bit on it, but not an expert. Brine is definitely at least a more effective option in that if you think about spreading, like crystallized road salt, one of the things you'll notice if you're running behind a truck that's spreading salt is it's bouncing off the road, it's going on the roadside. Brine adheres to the road better, so they can apply less and get the same results. There's less waste from using rock salt, which in some cases ends up in other places. The trade-off to that again is brine is expensive. It's expensive to get started for a municipality to do brine because it needs to be mixed correctly. There's special equipment to mix it. The trucks have special equipment to apply it then, and there is a slender threshold for the mixture between salt and water to form brine that makes brine most effective. So again, it's an education component too, where it's a big initial upfront investment for a municipality that will pay off in the long term. But again, it has to be, in some cases, a municipality that's in the position to do that.
Thanks, Ryan. Another comment, perhaps educating the public will eventually demand a change to their municipalities' practices. Yeah. Yep.
Yeah, so that's one thing that we sort of encourage. Again, we talk to our municipalities a lot about a lot of stuff, and if we complain about salt, it's like, oh, well, they're just complaining about something else. So when we have residents who email us about road salt and maybe there's a pile at the end of their street or some of our volunteers, we encourage them to reach out to their municipalities and their commissioners because that's their constituents. It's going to be more impactful hearing from them and hearing from a lot of them than versus just hearing from us who are paid people to talk about and care about this stuff.
Thanks, Ryan. It is 7:30 and I don't see any other comments. I'm gonna stop recording. But